And we're back. Day 2, linear programming. Essential question. How do I solve linear programming problems?
Good question.
And write that down, please.
Yes. Okay. So we're going to look at this word problem. And when I go through word problems, just like the last one, we like to kind of color code.
Yes.
So let's just start. It says a bookstore manager is purchasing a bookcase. Sorry. The store needs 320 feet of shelf space total. So that's total. They need at least that much.
Yes.
So I'm just going to quick write just a little less than sign so I remember. Wait. At least.
Is the other way around,
so it's going to be greater than.
Yeah,
they need at least that much.
At least, but yeah.
Silly mistakes we all make. Okay. So bookcase A, so I'm going to just highlight that one. Bookcase A provides 32 feet of shelf space and costs $200.
Okay.
Bookshelf B provides 16 feet of shelf space and costs $125. Because of space restrictions, the store has room for at most 8 bookshelves or bookcases for A. I'll just kind of just do it all.
And at most, that would be less than or equal to. That'd be less than or equal to by the 8.
Okay.
Okay.
Less than or equal to. And then
at most again
12 a bookshelf B.
So that's also a less than or equal to.
Less than or equal to. Okay. How many of each type of bookcase should the manager purchase to minimize the cost? Now you had a key thing to say here about this money up here.
Yes, let's talk about that. The minute you see money in any kind of linear programming problem, actually, I want you to cross it off right now because we are not going to use the money until we get to the final step, which is the objective function.
Right, when we solve it.
Right. So the key focus right now is to get our constraints. And students want to use that money, and we don't want you to. So cross it off right now. And can you do one more thing for me? At the top, the store needs 320. That really should be greater than or equal to.
Gotcha.
Okay.
Yeah.
All right, so let's start. Well, I'm going to scroll down a little bit so Miss Boyd has more room to, look at all this nice room I've given you today.
Nice, thanks.
So X is bookcase A.
Change this color real quick.
Perfect.
Keep going.
Y is bookcase B. And so remember last video, what did we talk about? There's 2 constraints that should be immediate in your mind right now with X and Y.
They always have to be bigger than 0.
Right, because can I have a negative number of bookcases?
No.
Oh, no, that's pretty silly.
Okay.
So our first constraint should be X greater than or equal to 0. And the second constraint?
I'm going to highlight that so we're on the same color.
Oh, I like that.
Going on.
And then B is Y. Y must be greater than or equal to 0. That's kind of a given every time you're doing constraints.
Okay.
Okay. So now let's go back and use the information we know. Let's start with the part where you wrote less than or equal to signs in blue.
Okay.
It says, because of space, the store has room for at most 8 of bookcase A, which we're calling our X.
Yep.
So at most means X then must be less than or equal to 8.
Okay. And I'm going to color code that
yellow,
so we keep yellow and
You can't have any more than 8, but I can have up to 8.
Okay.
And B, the same thing. They have room for at most 12. So that has to be Y less than or equal to 12.
That makes sense.
There's 4 constraints right there.
Perfect.
We still have to have one more because you see the 32 feet, I see the 16 feet. I know I'm going to use it, and the 320. So our final, and I'll scroll down a little bit, or do you want to write it over there?
I'll just write it over here.
How much room? Can I just scroll down just for a minute? See how much room we have? Oh yeah, because we have the graphing. That's the next. We have so much room.
Yeah.
Okay. So we can see the wording. So it says the store needs 320 feet of shelf space. So let's put that way over to the right.
Yeah, we said that was the greater.
Yeah, let's put that way over to the right.
Greater than or equal to
320.
Okay.
So what it's saying is it needs 320, but if these shelves take up more than that, that's okay.
Okay.
Okay? They're going to take up at least 320, but they could take up more.
Okay.
So bookcase A provides 32 feet of shelf space. So we have to take 32 times X.
Because that's bookshelf A.
Plus bookshelf, bookshelf B takes up 16 feet of shelf space. So that would be 16 times Y. And the reason we're saying 32 times X and 16 times Y is because each bookcase takes up 32 feet. So if we have 5, you got to take 32 times 5. So we're taking 32 times 8. And each of bookcase B takes up 16 feet. So one bookcase takes up 16 feet. Okay.
That makes sense.
Are we good?
Yeah.
There are our 5 constraints. That's the hardest part of the problem. So let's go on to the next page. Now notice, graph the feasible region. So What we have to do actually right now, we
I'm gonna
really
go off
should
to the side.
write
Yep.
the constraint up
Okay.
there. So I'm going to tell you right now, x greater than or equal to 0, y greater than or equal to 0, x is less than or equal to 8, and you should be writing this down.
Yeah.
Y is less than or equal to 12, and then 32x plus 16y is greater than or equal to 320. Now,
Okay.
this feasible region is really important because in these problems, you need vertices, and if you don't graph it right, you won't get the right vertices. So
Okay.
let's start with the top two. Pretty
Okay.
easy, right?
Yeah.
X greater than or equal to 0 and y greater than or equal to 0 are just the two x and y axes.
Yes.
So that's done.
Okay.
We really don't have to do any more.
Gotcha.
Unless you want to highlight
So
something.
is this our x greater than or equal to 0 though?
Mm-hmm.
Okay. So I'm just gonna do that one here.
Okay.
I'm actually gonna change these colors just so that we can see.
Okay. Sure.
Whoops. Okay, so we got the 0.
Right.
Then we got y
Mm-hmm.
was
Greater than or
equal to 0.
And our little equal sign erased
Yep.
up there. See that?
Okay.
Yeah.
So then that's this one
Right.
here.
Yeah.
Okay.
So there's two lines. So now x less than or
I'm
equal
gonna
to
change this
8.
one
What
to
should we change that to a different color?
Yep.
Okay, we're going to change that to green.
X
I like all this
less
color
than
coding.
or equal
And that's why we said use either
Eight.
markers, colored
Yeah.
pencils, whatever it is.
So it's
So
where
that's
8 crosses
right.
X.
So let's
Should
count
we do
1.
these by 2s or by?
No, let's go by, oh, never
Yeah,
mind.
let's go by 2s.
I lied. Yeah, let's go by 2s.
So 2, 4,
4, 6, 8.
8.
Here we go.
Now let's do a couple
10, 12,
Okay.
and so forth.
And
okay.
it's X, so it's where it crosses the X-axis. So
Mhm.
it will be a vertical line at 8.
Mhm.
So it's very important that you kind of get your lines exact on these
Right.
because we're going to need to find points after this.
Right. So we're going to do our best. Okay, so now y less than or equal to 12, that's going to be a horizontal line. So do we have another color?
Yep. we'll go
Black. Okay.
Y less than or equal to 12.
And that's going to be a horizontal line.
Going across the
So let's
y-axis.
count out by 2s again.
Okay.
So 2, yeah.
4, 6, 8, 10, 12, 14.
We're going to need to go to 20.
All right.
Yeah.
Perfect.
'Kay.
Okay. So across at 12.
Mhm.
So right here.
Perfect. We have 4 lines now. We need one more line. We need a final line that we're going to make. But notice the easiest way to graph 32x plus 16y is to get the intercepts.
The intercepts, yeah.
So let's find an x-intercept and a y-intercept right
Okay.
now.
So 32x plus 16 times
Times
0
0, yep.
is greater than or equal to 320.
So now we're getting the x-intercept.
So that goes away, and I'm just left with 32x
Mhm.
is greater than or equal to 320.
And if you
Divide by 32.
right, you're going to get 10. X greater than or equal
X
to
is greater
10.
than or equal to 10.
So let's write the point.
So
The
that's
point's going to be
10,
10, comma 0.
0.
So we could plot that point right now.
Okay.
What color do you think?
I'm trying to find a
We don't
different
really have any
color.
other
don't
colors,
have
do
any
we?
other
So we just stick to
colors.
black then?
Yeah, let's
All
stick
right.
to black. So
So-
over 10 and not up any.
There we go, right there.
Right there.
Now let's find the y-intercept.
Okay.
So 32 times 0. Mm-hmm.
Plus 16
Y.
is,
Mhm.
oops, wrong way, is greater than or equal to
Mm-hmm.
320.
Yep.
All right,
And
so
that-
that cancels there. We're left
Mhm.
with 16y greater than or equal to 320.
Right.
And this is why Miss Young said we're going to need 20 because
Yeah.
when we divide, we
You
get,
get 20. And so that the y-intercept is
So
going to
it's
be 0,
0,
comma 20. So if we plot that point,
So we don't go left to right, but we all go all the way up to 20.
yep. So
All right.
now, can we
Oh,
draw that
boy.
line? Oh, okay. So
So-
I'm going to give you a little hint right now.
Okay.
That can you maybe,
Kinda
I'm going to
go
give
through
Miss
here.
Boyd a little help here. We need to go through 412 and we need to go through 812.
That's over here.
Yeah.
But what one down here do I need to
Oh,
go
down
through?
there, 84.
8-4. So normally you wouldn't know this, but
Yeah.
when you draw your straight line,
It would go right through.
hit
We
the
struggled.
Y,
It's
but we
really
struggled
hard
with
for Miss
straight-
Miss
oh,
Boyd to
boy.
do this.
Let
This
me
is
start
not
over.
easy at all drawing these lines. So that's why I'm giving her a little tip to help get this line as best we
Let's try
can.
this again. So it
Okay.
needs to go through
That point.
there.
Yep. Keep going. You're fine. You're gonna do it. She's doing it.
All right.
Yeah. Okay.
Now
So
we're
let's
drawing this line again.
and that point up there should be 412.
So we hit it here,
Yep.
and that's at 4, 12.
Yep.
And we hit it here, which was at
8, 4. And you're not going to know those vertices till you're done, but you're going to have a ruler. We don't have a ruler. We can't use a ruler, and it's kind of hard. So now the shading begins. Okay, so x greater than or equal to 0, obviously that just means to the right.
This way.
Yep, so we're going to the right. And I like Miss Boyd's doing little arrows. We're going to see where they all overlap. Remember, the feasible region is where all of the arrows are going to overlap. Y greater than or equal to 0 is going up.
Oh boy.
That's all right. She's going a little bit to the left.
Okay, there we go. There we go.
We're struggling just a tad. There we go.
Okay.
The green, x less than or equal to 8. See the green line?
So it's going to go this way.
And notice, right now, they're all kind of overlapping in that triangle. And then the last one, now remember, for the last line, you can't just assume it's going above or below.
Well, we got to do this y less than 12.
Oh, sorry about that.
So y less than 12.
Oh, yeah. See, right now we're in the triangle.
All in the triangle still.
And our last line is we got to make sure, are we shading above or below? So if let's just do a test point, and that would be 0, 0. So if we plug 0 into 32x plus 16y,
2 times 0
plus 16 times 0
is greater than or equal to 320.
And the question is 0 greater than or equal to 320? Absolutely not. So that's why we're not shading below the black line. Maybe show them what black line I'm referring to.
So this black line she's talking about.
Yep. We're not shading below that line.
I'm going to just highlight now where we're going to be shading.
I think that's a wonderful idea.
Above it.
Yep.
Which is in this
and we're
green.
all...
And I'm just stopping by that green line because I already know I have to shade to the left of the green.
Right. So once you get your shading done, that's when you find your vertices.
Right.
We've already found 2 of them, 4, 12 and 8, 4. But notice there's another vertice, and that's going to be at 8, 12.
8, 12. All right.
So those are our vertices. And it's very critical because we're going to now, if I go down below here, we're going to write those vertices right here.
Okay.
The vertices are 4, 12, 8, 12, and 8, 4. Why are the vertices important? Because the vertices are used in our next page to evaluate the objective function. So now,
this is where the money comes in.
Right. This is where the money comes in. So maybe I should float back a minute so everyone can see what we're talking about. Let's go back to the money.
And I'll erase them now.
Perfect. Notice bookcase A costs $200 and bookcase B costs $125.
Okay.
So, and that's per bookcase.
Right.
Okay, so now we'll go back. So our objective function then is going to be P. We always say P. That's our, you think about it, that's our,
whatever.
exactly.
Okay.
And because it says, what are we, let me do one more thing, Miss Boyd, I apologize. Let's look at the question. What are we trying to do?
How many types of each?
Right, how many types of each bookcase should the manager purchase to minimize the cost?
So get the lowest amount
Right,
of money.
and we're using P. P goes with objective function. If you want to use C for cost, it doesn't matter.
Okay.
So we're trying to find, we want to minimize the costs. So here we go. Let's go back. Okay, so the objective function is going to be 200 times X.
How much?
Each
the first A cases.
And then you're going to add to that 125 times Y. Because each...
25Y.
Yep, because every bookcase of... every B bookcase
is $125.
Is $125, correct. So now what you're going to do is... Yeah, that's it. Perfect. That's the objective function. There's a nope.
Because that's what we're trying.
Right. So now look what it says. Evaluate the objective function at the vertices of the feasible region. Okay. So why don't we? What I kind of do? Yeah. So I kind of write, vertex, right?
Sure.
Or vertices, whatever. Vertex, and I draw a line and I write them all out. So 4, 12. We've already found these. 8, 12. And the next one is going to be 8, 4. And what I would do, sure.
Or do you want me to
write it? Write it right there. Okay. P equals 200x plus 125y. This is actually the easiest part of the whole problem. Maybe draw a line. You want to draw a line underneath that. So there we go. All we're doing now, so P equals, and you're plugging in 4 for x, and you're plugging in 12 for y. That's why this is the easiest part of all. So P is equal to, when you do that, you get,
I don't know.
Let's see, 125 times 12.
Let's get the answer.
Yeah, because you know what? Really, they know how to, that's why I didn't show all those steps. The answer to that is 2,300.
All right.
They can do that.
Good.
Or is that one? Let's try the next one. 200
and this time I'm plugging
times
in
8 plus 125 times y. And when you do the math, plug it into your calculator, you're going to get 3,100.
Okay.
And the last one is
200 times 8 plus
125 times 4. And that is equal to 2,100. So now we have to answer the question.
Yeah.
How many
minimum.
how many of bookcase A and how many of bookcase B are we going to make to minimize the cost? Well, which one has the lowest cost?
Here's our lowest cost.
There we go. So we have our answer.
So here are our answers.
So then maybe we'll write
bookcase
8.
A.
Yep, bookcase A, we're going to make 8 of them.
We need
8. And bookcase B.
Bookcase B.
Do you have enough room? Or
Yep, I'm
okay,
good.
all right. Is 4.
And
that
that's
is
our
it.
answer.
That's how you're doing. So if they would have said, Miss Boyd, we want to maximize profit, let's say.
Oh, yeah.
Obviously, then we would have chosen 3,100, and then we would have made 8 and 12. So you really have to read the question. Are we minimizing or are we maximizing? And that is the purpose of the objective function.
Perfect.
Let's go to the next page because I think there's nothing there. And here are your video questions. We will see you tomorrow.